Alright, so we've got a couple examples here, and I would like just to stress and remind you what are the difference of squares and the perfect squares. So the difference of squares is when you have two numbers which, well, they are subtracted, so that's a difference, and they are both the square of something. So that's why it's called the difference of squares. And this is the same thing as a plus b. In this case, let's assume both numbers which are squared are a and b. We've got a plus b and a take away b. So this is the difference of squares. Oops, difference. It's hard to write with that. All right. Now the other possibility, the other useful, let's say, expression is what we call the square, the perfect square. So we've got a plus b, or this may also be a minus b. So let's do a plus b. Whenever you have a plus b squared, okay, a plus b open inside of brackets, you will simply have a squared. Oh, you don't need the brackets here. Okay, so a squared plus 2ab plus b squared. We've done that several times in lesson, and that should be natural to you by now. If it's not, go back and do some revision exercises regarding perfect squares. Also, this might be negative, and then if it's a minus b, everything will be the same despite the sign. So if it's a minus b inside of brackets squared, you will have a squared minus 2ab plus b squared. Okay, given that, let's solve some problems. Let's apply our knowledge, right, to some problems. So let's take a look at this first example that we have here. X squared plus 10x plus 25. Remember that we're going backwards, right? We are not expanding anymore, we're factorizing. So we're going from the right here, right, into the left. That would be our factorization. Right, so when you factorize, you're going from something which is expanded back to how it would be before you expand it. So let's do this one. So x squared plus 10x plus 25. If you remember one of the techniques that we have learned, summing product, you could already apply to it. But if you notice, this is x squared plus 2 times 5 times x plus 5 squared. Oh, this looks awful. Let me just rewrite that. I will omit all the multiplication signs. Okay, so that's 2 times, I'll just put a point here, times x plus 5 squared. Right? Okay, so x squared plus 2 times 5x plus 5 squared. So take a look, 5, that's our b here. 5 2 times something, it's 5, and a would be our x. So this can be rewritten as simply x plus 5 squared. If you're ever insecure, you can expand back and you should get back to your answer. So that would be x squared plus 5x plus 5x, so that's plus 2 5x plus 5 squared. Now let's take a look at the second problem. So the second one here, I've got minus 8x squared minus 24 minus 18. So first thing we should look for is common factors. So do we have any common factors? Well, it seems so. Let's try to rewrite those as the numbers which multiplied gives us those numbers. So negative 2 times 2 times 2, which is 8. X squared, right? Negative 2 times, to get 24 it would be 12, so that's 2 times 3 x. If you multiply back, you will get 24, right? 2 times 3, that's 6, times 2 12, times 2 24, minus 18, that's 2 times 9, so that's 2 times 3 times 3. So let's see, we've got negative 2 as a common term to all of them. So do you see that? So negative 2 in all of them. So I can first factorize. So what we're doing here is, before we're looking for any perfect square or difference of squares, we're first factorizing. We're looking for common factors. If you can do it straight away from here, that would be fine. So if you can observe, this is an even number, this is an even number, this is an even number. They're all even, so they can be divided by 2. And also they are all negative, so negative 2. Okay? So if we go now forward again, this is, well, 2 squared x squared. Right? 2 times 2, that's 2 squared. Now, this has been factorized, so it's not negative anymore, and also this 2 is here up front. So what do I have left? 2 times 3 times x. So, well, okay, plus, I'll put this 3 forward and multiply this by 2 and 2x. Because then you can observe that, well, this first term looks like 2x squared. And I've got 2x here as well. Well, let's continue then. So this becomes positive, and this is simply 3 squared. Right? So this is all equal to, equal. Now, well, I can now rewrite this. This is 2 times, right, sorry, negative 2 times 2x squared. And then I will have, this is my a, this is my b. So 2 times ab. So I've got 2 times 2x times 3. I'm only putting brackets here to make it clear that it's that it's 2 times the first term times the second one. So take a look, 2x is here and here, and 3 is here and here, and that's 2 times 2x times 3. So we can finally get to negative 2. So this is a perfect square. And since this sign is positive, that's the first case that we have here, all in blue. So a plus b squared. So that's 2x plus 3 squared. So 2x plus 3 squared. And that's done. That's the answer. Don't forget the negative 2 that you had in front. Because sometimes we're dealing with so many things in here that we forget that we were multiplying all of this by something. And try not to get, scared or insecure when you see loads of numbers and loads of things being multiplied in large numbers. Just try to break them down if you cannot see straight away which are the factors. If you can, please go forward. You don't have to do exactly all of those steps. You can skip some of those if you find those, too much. You don't have to do any of those. That's fine. If you can go straight to the last, or straight to, one of the the second one and the fourth one, that's perfectly fine. That means that you don't have to do all of those steps, and that should be fine as well. All right, so those should be good examples of perfect squares.